Okay, so today we will be covering an important topic which has often been asked in the UPSC civil service examination. The topic is albedo. Now, as we will be seeing, why is albedo important? Albedo is important because of its usual reference whenever we talk about global warming, right? Before we understand what is albedo, we need to understand certain important concepts to form an understanding about albedo. Now, what are these concepts? We need to know what is insolation and what is terrestrial radiation. Why are these two important for the understanding of albedo? Because these two, they tend to balance each other and maintain something that we call as the heat budget of the earth. Okay. If the insolation was not balanced by the outgoing terrestrial radiation, then earth would not have been able to maintain its average temperatures, right? So earth as a whole does not lose or gain heat in a year. That is because the insolation is balanced by the terrestrial radiation. Now we need to know what is insolation and what is terrestrial radiation. First we will be talking about insolation. In simple terms, what is insolation? Insolation is the incoming solar radiation. Incoming solar radiation or the incident solar radiation. The radiation or the rays that we receive from the sun, we have a term for those, that is insolation, right? Insolation is the incoming solar radiation that is received on the earth. Now we know that ultimately all energy that we have on earth is directly or indirectly sourced from solar radiation, right? Now there are certain factors on which this incoming solar radiation is dependent and varies. It is different for different locations on the surface of the globe. It is different even for the same location at different times of the year. That is, the radiation that is received on a particular place on the surface of the earth is dependent on a number of factors and varies from day to day, right? So what are these factors on which the amount of radiation received at a place on the surface of the earth is dependent? These factors are the rotation of the earth on its axis, right? The angle made by the incident radiation on the surface of the earth, the transparency of the atmosphere, and the length of the day at that particular place. More the length of the day, more is the time that is available for the incoming solar radiation to strike. And last is the configuration of the surface. Right, so these are the factors on which the amount of radiation, incoming solar radiation received on a particular place on the surface of the earth depends. Rotation of the earth on its axis, angle made by the incoming radiation on the surface of the earth, the transparency of atmosphere, the length of the day, and configuration of the surface. Also, another thing that we need to know is most of the radiation that is received on the surface of the earth is in the short wave form, right? So we have long wave radiation, we have short wave radiation. The incoming solar radiation or insolation is short wave radiation, right? Why this is important is because our atmosphere is transparent to most of the insolation because of the fact that it is short wave radiation. How this is important for the heating of the atmosphere? This has been covered in the climatology concept, that our atmosphere is indirectly heated by the terrestrial radiation, which is long wave radiation, and not by the insolation, which is the short wave radiation. Now we will be covering the factors one by one. Now, for example, this is your Earth, right? This is the equator, Tropic of Cancer, Tropic of Capricorn, right? And these are the poles. Now, the insolation received at a particular area depends on the angle made by the incoming solar radiation. Now, how this is important is, now suppose this is a particular area, right? If the rays, they strike vertically at this point, the rays will be covering a smaller area. There will be more incident radiation in a particular unit area, therefore more heat is received, right? If these radiations, they are received obliquely, they cover a larger area, therefore the heat is dissipated, right? So insolation depends on the angle of the striking radiation. Now this angle varies with latitude, right? The angle that is made by the incident or incoming solar radiation on the surface of the earth depends upon the latitude of the place. Higher the latitude of the place, lower is the angle that is made. That is, lower angle means higher the latitude, more slant are the rays that are striking the surface. If this is your equator, the rays are striking more or less perpendicular. So more insolation or more heat is received. Here, if these are striking, the angle has decreased. That is, the obliqueness or the slantness of the rays has increased, right? So the angle made by the incident or incoming solar radiation or insolation at a particular place depends upon the latitude of the place. Higher the latitude, lower is the angle made, or more oblique are the rays. Right, so this is an important determinant of the insolation that is received at a particular place on the surface of the earth. Now it has been observed that if we have to calculate, the insolation that is received at the tropics is around 720 units approximately, and incident not 720, it is around 330, around 300 units, and that received at the equator is around 70 units, right? The highest amount of radiation is received in the subtropics. Why subtropics receive more incoming or incident solar radiation is because they lack cloud cover. The cloud cover is the least on subtropical deserts, therefore they receive the highest amount of